All right, welcome to the next lecture, 3.4, which is on exponential and logarithmic equations. Okay, they're actually, one of the nice things about this section is that there isn't really anything new. Okay, it's just going to be using the same ideas that we've been using the last couple of lectures. So let me move this real quick. Okay, so let's start. Let's get right into examples. Let's solve 4 raised to the absolute value of x equals 128. Okay? Now, there's two ways to solve this that I can think of off the top of my head. First way is to notice that 128 equals 2 to the 7th. So you may or may not notice that. Okay, if you do, that's good. So then you have 4 to the absolute value of x equals 2 to the 7th. And 4 is 2 squared. So you can write that as 2 to the 2x. Absolute value equals 2 to the 7th. Now, once we have the bases being the same, you can say 2, absolute value of x is 7. Absolute value of x is 7 halves. So x is plus or minus 7 halves. Okay? Perfectly acceptable way to solve it. But it requires you noticing that 128 is 2 to the 7th, or 128 is a power of 2. Okay? If you didn't notice that, then you might just say, okay, let's start with 4 to the absolute value of x equals 128. And you might decide to take the natural log of both sides. It's what we were doing last time in the 3.3 lectures. Okay? So if you did it that way, natural log of 4 to the absolute value of x equals natural log of 128. Then we're going to bring this absolute value of x in front. Okay? So absolute value of x, natural log of 4, equals natural log of 128. So absolute value of x equals natural log of 128 divided by natural log of 4. Okay? And if you do that in your calculator, you do in fact get 3.5. Okay, which is 7 over 2. So x is plus or minus 3.5 or plus or minus 7 halves. If they ask you to write it as a whole number or a fraction, you have to write it this way. Okay? So that's sort of where you don't get anything for free usually. All right, let's take a look at another one. Let's solve log base 4 of x equals negative 2. Okay? There's actually not much to this. We're just going to write it immediately as an exponential equation. 4 raised to the negative 2 equals x. Now 4 to the negative 2 we know is 1 over 4 squared. That equals x. And 1 over 4 squared is, of course, 1 over 16. All right? Okay, next one. Next one's kind of like what we did at the end of the 3.3 lecture. So, solve 2 to the 2 minus x equals 3 to the 5x plus 6, and it says to 3 decimal places. Now, anytime I'm asked to solve to some sort of approximation, I try and avoid approximating as long as I can. Okay? I avoid approximating as long as I can. So what I do is I do all the work algebraically by hand until I get one expression at the end. Okay, so doing exactly what we did last time, we're going to take the natural log of both sides. So taking natural log of 2 to the 2 minus x equals natural log of 3 to the 5x plus 6. Now with the natural logs, remember, the powers will come in front. Okay, so 2 minus x times natural log of 2 equals 5x plus 6 times natural log of 3. Next thing I'm going to do is I'm going to distribute that natural log of 2, and here distribute the natural log of 3. So 2 natural log of 2 minus x natural log of 2 equals 5x natural log of 3 plus 6 natural log of 3. Okay, next thing I'm going to do, we're going to group these terms with x together. So let's go ahead and put everything with x. We're going to put everything with x on the right side, just because I don't like minusing. It's my own little thing. So we're going to put that over here, move that over there. Okay, so 2 natural log of 2 minus 6 natural log of 3 equals 5x natural log of 3 plus x natural log of 2. Next step is, of course, I'm going to factor out the x. Let me put that 2 there. I'm going to factor out this x. Okay, so 2 natural log of 2 minus 6 natural log of 3 equals, factoring out the x, 5 natural log of 3 plus natural log of 2. Now, next thing I'm going to do, I'm going to divide this term on both sides. Okay, so we're going to get 2 natural log of 2 minus 6 natural log of 3 divided by 5 natural log of 3 plus natural log of 2 equals x. Now, at this point, you could plug this into your calculator. Okay? However, a lot of you aren't calculator wizards, and so you might mess this up. Okay? Just saying, I know I'm capable of making a mistake on this. So what I thought is, let's go ahead and use our logarithm rules to simplify this expression. Okay? So x equals, I'm going to write this as natural log in the numerator. Well, the 2 comes back here, so that becomes natural log of 4 The 6 comes up here. 3 to the 6. So let's write this as natural log of 4 minus natural log. I'm calculating 3 to the 6 right now. 729. Divided by natural log. We're going to do the same thing. 3 to the 5th. I should have that as 243. Plus natural log of 2. Now, I can just write that as natural log of 4 over 729 over natural log of 243 times 2 is 486. And this is a lot easier to calculate. Okay, that's a lot easier to calculate. I'll just do that real quick. 4 over 729 divided by 486. And I get negative 0.8414. Now, I always go one more than what I do, and then I round it. So the rounding is negative 0.841. Okay? So that's your rounding to 3 decimal places. All right, I'll be back in the next video.